Hello, and welcome to our Giant Leap podcast, presented by the Space Generation Advisory Council. Our Giant Leap discusses diversity, equality, and inclusion issues within the global aerospace industry. My name is Stephanie, and on today's episode of Space Chronicles, we're going to talk about whether or not Interstellar captures the truth about black holes and feature the female scientist who led the effort in the creation of the first picture of a black hole. The topic for this episode was inspired by the dramatic scenes in the movie Interstellar that featured the fictional black hole Gargantua. If you haven't seen Interstellar, first, I would highly recommend watching it. If you're listening to this podcast, I assume you're interested in space, and the movie presents an interesting and exciting depiction of a fictional future in space. Without spoiling the entire plot, the basic idea is that when Earth is no longer able to support humans, NASA sends astronauts to visit 3 potentially habitable planets that are orbiting Gargantua. The effects of the black hole and traveling near it drive many of the challenges that astronauts face with their missions. There are several beautiful shots of the black hole, which had me thinking about whether this is an accurate portrayal and if astronauts would be able to safely visit planets that are orbiting a black hole. So I did some research, and I found that the visual depiction of Gargantua is considered the most accurate in a Hollywood movie, and Christopher Nolan, the director, actually consulted with theoretical physicist and Nobel Laureate Kip Thorne on the depiction of Gargantua. Dr. Thorne won the Nobel Prize in Physics in 2017 for his work on the LIGO detector, which was used to detect gravitational waves. 2 black holes colliding created the gravitational waves that were discovered in 2015. So that brings us to our first busted black hole myth. Myth number 1. If you get anywhere near a black hole, it will pull you in, or black holes are hungry and search for planets to eat. So the truth is that black holes are very massive, but they don't suck things in any more than how their gravity pulls things to them, similar to how gravity works on Earth. A black hole that is 10 times the mass of the sun has the same gravity as a star of the same size, and it is possible to orbit a black hole. Some of why we know the portrayal in Interstellar is so accurate is because of the famous black hole image that was published in 2019, which brings us to our discussion of Dr. Katie Bouman. Many of you have probably seen the black hole image that I'm talking about. It basically looks like a glowing orange donut on a black background. If you haven't seen it or you aren't sure what I'm talking about, we've linked the image in the episode description so you can get up to speed. That image was made using a computer algorithm that processes data from several telescopes. So that brings up the second black hole myth. Myth number 2. Nothing can ever escape a black hole. The truth is that radiation can escape from a black hole, and if a black hole emits more radiation than it absorbs, it will eventually evaporate, which happens very slowly. So black holes can shrink over time, rather than this sort of typical idea of them becoming more massive as they eat up everything around them. This radiation is one of the wavelengths that was picked up by the telescopes and used to make these images. So if you've seen this black hole image, released in 2019, it's likely that you've also seen the picture of Dr. Katie Bouman looking on with excitement while the image renders on her computer. Dr. Bouman was a key leader of the team that developed the image, starting when she was a graduate student at MIT. Dr. Bouman posted the photo to her own personal Facebook, for the record, with the caption, quote, "Watching in disbelief as the first image I ever made of a black hole was in the process of being reconstructed." This post was screenshotted, it was tweeted by other people, and ultimately went viral after being retweeted by the research lab MIT CSAIL. A campaign began to discredit her after Reddit users went through the GitHub of the algorithm used to synthesize the image and found that Dr. Andrew Chale was listed as the primary contributor. The argument that Dr. Bouman was getting a disproportionate amount of credit centered around a fundamental misunderstanding of the GitHub commits for the algorithm. Trolls said that Dr. Chale wrote 850,000 of the 900,000 lines of the code, but he said that many of those lines reference model files and aren't representative of the effort. He's quoted saying, "There are about 68,000 lines in the current software, and I don't care how many of those I personally authored." For the record, some of this backlash was for the media framing specifically, not for statements made by Dr. Bouman. She never claimed full credit, even saying to CNN that, quote, "No one of us could have done it alone. It came together because of lots of different people from many different backgrounds. The good news is that Dr. Chale stepped up to defend Dr. Bouman on Twitter, saying, quote, "I'm thrilled Katie is getting recognition for her work and that she's inspiring people as an example of women's leadership in STEM. I'm also thrilled that she's pointing out that this was a team effort, including contributions from many junior scientists, including many women junior scientists. Together, we all make each other's work better. The number of commits doesn't tell the full story of who was indispensable." I have really mixed feelings thinking about how this backlash was handled. So, on one hand, it's nice that Dr. Bauman's colleague demonstrated some allyship for a minority member of the community, but at the same time, she shouldn't need a man's voice to lend her credibility. She's clearly an accomplished scientist in her own right. What I really want listeners to take away from this story is that you shouldn't let haters or internet trolls make you feel like you need to diminish your own efforts. If you're doing cool research, publish it. Be loud and proud about your academic and career accomplishments. Your work will ultimately speak for itself and be much more powerful than the people that are trying to silence it based on their own prejudices. Dr. Bauman's black hole image is not only a major leap forward in scientific understanding, it's also exponentially more famous than anyone who tried to tear her down. I wanted to leave everyone with one final busted black hole myth, mostly because I think the terminology from the field is funny. So myth number 3, if you somehow fell into a black hole, you would be crushed by the pressure created by a black hole's density. So the truth here is that there is a word for what would happen if you fell into a black hole, which is spaghettification. The gravitational field becomes so intense that the force on the side of your body closer to the black hole would be noticeably more than the other side, and you'd be pulled and stretched thin and eventually pulled apart. This might not be a more comforting thought than being crushed, but your risk of falling into a black hole is really small. So we can laugh about the word spaghettification without being too worried about our safety. Astrophysics is such an interesting field to study. There's so much that we still don't know about the universe, which means that there's also lots of opportunities to do unique and engaging research. But even more than my personal passion for space, I think what I find so moving about the picture of Dr. Bauman, watching something she worked really hard on finally pay off, is that you can see her love for her work all over her face. It's exciting to imagine something that you've poured yourself into having such a big impact. So whatever you feel passionate about, I hope that this story motivates you to chase after it. And if you need a little morale boost, maybe you should print a copy of that black hole picture to tape to your desk. Thanks everyone for listening. We'll include some links to articles on black holes in the episode description if you want to continue your learning. For more information and resources, please visit the Diversity and Gender Equality Project Group website as part of the Space Generation Advisory Council. Looking forward to seeing you next time. I'm your host, Stephanie, signing off.